Assalamualaikum and good day. My name is Amira Nuri Shazim binti Abbas and I'm going to present about integrating landslide susceptibility mapping for disaster risk reduction. On this context, we're going to through all the context such as introduction, overview of CIRIPAC project, project scope and goals, methodology, result, challenges and solution, impact and benefit, future recommendation, and lastly, conclusion. Firstly, introduction. This project performed an intermediate analysis that predicts CIRIPAC Zone 1 landslide. It helps to assess and reduce CIRIPAC's landslide risk through calculating and displaying gentle foothill and step slopes. Due to geology, topography, and human activity, CIRIPAC is prone to landslide despite its beauty and growth potential. Here, urbanization and infrastructure development require landslide vulnerability assessment and management. WOE stands for Weight of Evidence was generated using geomorphological, hydrological, and anthropogenic causal factor maps. Landslide Susceptibility Index, which is indicated as LSI, computations created the landslide susceptibility maps. Next, we are going to the next topic, which is project goals and project scope. Project goals to increase awareness about landslide to audience or visitor. This is to prevent from the occurrence of landslide. While the project scope is by the stakeholder engagement, site investigation, monitoring, and maintenance. Next, this is the methodology which I will present step by step how this is work. Firstly, by making the process boundary of CIRIPAC. CIRIPAC have 4 zones which indicate different zone, and I pick zone 1 because the highest recorded visitor in the park. And also there is also many human activities in the zone 1 which specifically good for landslide susceptibility check. Next, making a spatial analysis process to each factor of landslide. Firstly, on geomorphological, geological, hydrotopography, and anthropogenic. And thirdly, by include the weight of evidence, WOE, for calculation from each landslide factor that I just said. You can see there's a formula which from the right to left, the right indicate the meaning of the formula that included in the left formula. Lastly, for the last step is landslide susceptibility index will be generated by adding all the layers. This is we call as LSI. This is the result output of this map. As the topic is called Integrating Landslide Susceptibility Mapping for Disaster Risk Reduction in CIRIPAC JB. So let's go into the first analysis which call of this first analysis by landslide susceptibility and land use distribution and area percentage. So I make this analysis from the pie chart that we can see. The color indicator of from the output map shows from very low to very high. So as we can see, I managed to find the 5 classes in here, which is very low, low, medium, high, and very high, which the percentage from 10.1% for very low 24.5% for low, 26% for medium, 21.4% for high, and very high indicate for 18%. In this, we can analyze and we can see that the medium has the highest percentage area for different landslide classes, which is 26% in the medium classes. This shows that the overall of the landslide is prone to very low to medium. Next, this is the second analysis that I make from the land use land cover area under very high and high landslide susceptibility index. So as we can see that agriculture has the highest percentage, which indicate 90% and 21% for the high and very high. This is because agriculture covered almost 80% of this zone 1. This is majority of roads in Sierra Park exhibit a high and very high invulnerability in agriculture to landslide. This location within area 80% covered and lack of protective measure. And the third analysis that I made And the third analysis that I made is the susceptibility of road of landslide Sierra Park. This is officially the classes of road only. This is the indicate the lake landslide inventory, and the LSI itself is only indicate to road that I made, and I found out that within the 5 classes, we can see that the highest susceptibility is high classes, which indicate 38%, 38% in the orange color in the pie chart. This is because the majority of the road in Sierra Park exhibit a high vulnerability to landslide. This vulnerability is primarily due to 2 key factors, which is their location with steep slope and lack of protective measure, since the road is not protected by anything. As we can see in the output map here, which is the landslide susceptibility index that I provided, here is the this is the main map, which is covered the whole Sierra Park. This area I have managed to separate, which the area zone 1, as we can see here, and this is the whole Sierra Park, which the biggest park in the JB that have been conservation with a forest conservation. So in the legend, we can see there is a building, road, lake, landslide inventory, zone 1 boundary, and the landslide susceptibility index from very high to very low. So by doing this landslide index, we can see that there is some area that prone to landslide, and this is the predicted area, which is in this area, and also this area. This is quite big place, and the place actually have another another area which is in area zone 2, but the first the first aim is from the zone 1. So that's why I click the map, and we can see this is the biggest area, while the visitor area is from the entrance, parking lot 2, parking lot 1, and this is actually the highest peak of Sierra Park and the road here. So mostly visitor will be going to almost this whole area, while this area is mostly from the hiking trails area, which not commonly for people who just want to spend time a little. So as we can see in the landslide inventory, uh, this area is have high vulnerability, and the grid code also show very high in this area. And this area also have the water bodies in the area, which mean this this is actually public area, which very concerned and need to take attention. While in this area also need to take attention because it's really beside of the road and the parking lot, which is have a lot of human activities, and actually this area have a lots of shop lots, food stall, and ATV area in this area, and this also. So this is the impact of landslide if this happen, that it will be harmful to the visitors. The hillside area that suffered from the landslide will affect the nearby residential area, because this this Sierra Park is actually at the center of the city. That's why the Sierra Park Conservation Forest is protected by the government. Hence, it's on the center of the residential, which full of other residents. Next is damage to infrastructure such as cracked roads and facilities. We're going to some site visit and some pictures that we take. That this area, we just go into this area, and there is some water leak in the drain and some moisture on the soil itself. But it's good because the tree have not fallen yet. So because of the management itself, they already put gabion in the area to make sure it's safe for the visitors. And the benefit of landslide it can provide, such as gabion as I said before, and a safer and more visual environment that could attract more visitors to support recreation activities such as hiking. So in my future recommendation here, I recommend that we have an advanced monitoring system to utilize advanced monitoring for early detection of landslide risk using remote sensing technologies such as drones, and more likely if they have a big budget, we can use satellite image, a good satellite image. Next is raise awareness, which to educate people about environmental issues such as climate change, pollution, deforestation, and biodiversity loss, because this forest is the center of the city urbanization. And the third is by localized monitoring. Rain gauge can provide localized data on rainfall variation that can be targeted monitoring areas that prone to landslide. As I said before, in the site visit, we can see there. Sorry. We can see that there is a soil moisture in the area, which mean there is spring water under the ground and that leaking without going to the drain. So by using rain gauge, the management can see and predicted the area landslide to prevent from the visitor come in. And lastly, for the converse resources to advocate for responsibility resource management by conserving water, energy, and natural resources, such as the slope steepness itself, that instead of making gabion that need more human activity to make the stone, to make the cement, and to gather the stone making itself uh, unstabilized and even leaking already. So they can just make they just can put trees such as vetiver grass in the picture here. The vetiver grass can we can see that the roots help the land for stabilizing. So this is a good idea for the to prevent the landslide happening. This is the challenges and solution, which the challenges is hard to obtain data, lack of knowledge, slow personal computer, miscommunication, while the solution is we can explore more data acquisition method, invest in upskilling and encourage knowledge sharing, upgrade and maintain hardware and software regularly, encourage the use of the simple language in communication. This is the impact and the benefit, which the impact of the landslide will be harmful to the visitor. The hillside area that suffer from landslide will affect the nearby residential area, which damage to infrastructure such as cracked road and facilities. And the benefit of this landslide mapping, which Zero Park can provide early steps such as making cabin and, as I said before, making farm for the grass. A safer and more visually appealing park environment could attract more visitors and support recreational activities such as hiking. This is the feature recommendation that I just showed in the map before. In the map just now, which is advanced monitoring system, risk awareness, localized monitoring, conserve resources. In conclusion, proactive risk management and mitigation strategies are crucial in addressing the impact of landslide in Sierra Park. The risks, including harm to visitors, threat to residential areas, and infrastructure damage, emphasize the need for comprehensive understanding and action. Implementing conservation and advanced monitoring system can mitigate these risks and create a safer, more visual appealing environment that attract visitors and supports sustainable development. By integrating these strategies into planning and decision making process, stakeholders can ensure the long-term resilience and well-being of Siri Park and its community.